This is part 2 of the video notes for Objective 4A, Solving Nonlinear Systems. In this part of the notes, we're going to focus on using the techniques of substitution and elimination to solve 3x3 systems. For our first problem, example 5 in our notes, we have 3 equations. And we're going to approach this one by using elimination. And I'm going to write the scratch work for the elimination method in a very specific way because I want to show hints and lead up to solving systems by matrices, which is our next goal, goal 4B. So here are our 3 equations, and we are going to attempt to eliminate the y's from each equation. So we're going to start by mixing equation A with equation B. So we're going to find equation A plus B. We've got 2x plus y plus z equals -2, and we have 2x minus y plus 3z equals 6. When we add these together, we get 4x, the y's eliminate, plus 4z equals 4. Go ahead and simplify this equation. They share a common factor of 4. So our new equation is equation D, and it's x plus z equals 1. Now we need to combine another pair of equations, either equation A with equation C or equation B with equation C to eliminate the variable y. Since equation A has a positive y and equation C has a negative y, I'm going to choose equation A and equation C. However, I'm going to do 5 times equation A plus equation C because I need this y to be a 5y so that when I add it with -5y, I get 0. Here I'll have 10x plus 5y plus 5z equals -10. For equation C, I'm going to copy it down as is, 3x minus 5y plus 4z equals 7. Add the equations together and you get 13x plus 9z equals -3. This we'll call equation E. When it comes to equation D and equation E, I can either continue using the elimination method or I can switch to using substitution. Because substitution is my preferred method, I'm going to go ahead and switch. I'm going to say that x is equal to 1 minus z. And I'm going to plug that in where I see an x in equation E. Distribute. And at the same time that I combine like terms, I'm going to go ahead and subtract the 13 to the other side. Z is equal to 4. This is the first of my 3 answers. Because I chose to use substitution method, I have an equation that says x equals in terms of z, and I can plug my 4 into this equation here. Now I know that x is equal to -3, so I can take these 2 answers and plug them into any one of the original 3 equations. Let's use equation A. 2 times -3 plus y plus 4 equals -2. -6 plus y equals -6 if I subtract 4 to both sides. So y must equal 0. The solution to a 3x3 equation should be written as an ordered triplet x, y, z. Let's try that again with example 6. Example 6 has 3 equations with 3 variables as well. So we have 4x plus 2y minus 6z equals 34. 2x plus y plus 3z equals 3. And 6x plus 3y minus 3z equals 37. For this particular setup, it looks like it's going to be easiest to solve for z because 6 is a multiple of 3, and I have both positive and negative variables. Let's call this equation A, B, and C, and it looks like I can add equation B and C without any additional work needed. So B and C together is 8x plus 4y cancels and is equal to 40. That divides by 4, so my new equation D is going to be 2x plus y equals 10. I'd also like to combine equation A with equation B, but I'm going to need to do 2 times equation B. So 2 times equation B is 4x plus 2y plus 6z equals 6. Equation A is 4x plus 2y minus 6z equals 34. When I add these together, I get 8x plus 4y equals 40. These are all divisible by 4, so my equation E is 2x plus y equals 10. Now I'm hoping that you notice something unusual about this solution. These equations are not only parallel, but they're identical. So I can't reach a solution using the values that I have so far. Instead of calling this system inconsistent, we want to call this system dependent. And no matter which equations I choose to pair up to eliminate, I'm going to end up with the same result each time. And that's because these equations are parallel. So the solution to this is a dependent system. This concludes part 2 of the video notes for Objective 4A, Solving Systems of Nonlinear Equations.